On November 8, 2020, Virgin Hyperloop completed its first passenger ride test with much fanfare. This 500-meter test run in a near-vacuum environment at the speed of 172 km per hour gave an additional boost to this technological innovation, which is getting many individuals and companies very excited. Indeed, since 2012, when Elon Musk revived the idea of the Hyperloop and provoked some serious attempts by developers to make it a reality, the Hyperloop term gained worldwide attention. This is to the point that many people have come to believe that the Hyperloop will, in a few years, become a reality, and that we will all be able to travel on it from Los Angeles to San Francisco in 35 minutes. While there is some possibility that this technology will fulfill its extremely high promise and deliver dazzling speeds of ground travel, there are also great reasons for skepticism. Many alarms are sounding off right now regarding the Hyperloop. Alarms that we should not ignore. One of the central ones is that the Hyperloop seems to fall into the trap of technological reinventism, which highly reduces this technology's prospects of becoming a reality, especially as imagined right now. In this video, I will explain the term technological reinventism and its main characteristics. I will then tie it to two specific examples: the Segway's reinvention of urban travel and the current Hyperloop reinvention of long-distance ground travel. So what is technological reinventism? Technological reinventism is the attempt of developers and innovators to offer a bold and radical different technological solution in a high-stake field in which many technological solutions have been tried. In such a situation in which many people have already tried to tackle a given set of engineering technological challenges, the current available solutions are usually pretty solid, and any radical redesign are much less likely to succeed. Think, for instance, of a technology that asks to reinvent how we prepare food in our home or to reinvent the workplace. Both are fields in which so many improvements have been examined and attempted by so many brilliant minds working independently that radical solutions are unlikely to succeed. What usually happens to technologies that offer such reinventions is that either the solution is discovered to be unpractical, or that the radical idea is diluted to something that isn't much more than an incremental change to what already exists. Take the Segway as an example. The Segway, when it came out at the beginning of the 2000s, asked to revolutionize urban travel with a vehicle that resembles nothing else that existed until then. The way that the vehicle balanced itself, the way that the rider was positioned, the way that it was powered, and the way in which the steering worked were all novel and thus helped deliver on the promise of a true reinvention of the field. Indeed, many of Silicon Valley's best minds bought into the idea and stated publicly that the Segway will revolutionize its field. In doing so, they contributed to the hype which has now reached stratospheric heights. While hype in itself should raise our alarm and skepticism, Reinventism hype should alarm us in particular. In the case of the Segway, back when it was launched commercially, skepticism already arose regarding its soundness. For instance, most of its novel features were questioned. The parallel wheel layout, which requires that the computer and the motor balance the vehicle at all times, were on the one hand a nifty feature that attracted people's attention and curiosity, and on the other hand a huge and unnecessary engineering challenge, safety-wise. Positioning one wheel behind the other, like almost all two-wheel vehicles, makes much more sense, and the risk of tipping over forward is greatly reduced. The reinvention of the Segway steering on its part is just a redundant feature. While again, this is a nifty feature that gives the rider a unique experience, steering a two-wheel vehicle was never really a problem that needed a solution. Once we learn how to steer a bike, steering all other two-wheel vehicles comes intuitively to most of us. On the contrary, learning how to steer a Segway requires getting used to because it is so different from anything else. Other problems had to do with the bulkiness and weight of the Segway, which complicated practical aspects such as where do I park it and how do I get it to my office at the third floor. It also became clear that the Segway's place isn't on the sidewalk because it is too big and heavy for it not to become a nuisance and a hazard to pedestrians. On the other hand, it is too slow to be out on the road. While today most large cities worldwide have enough bike lanes to accommodate such a vehicle, at the beginning of the 2000s most didn't, which made the Segway's promise to reinvent urban travel a remote possibility. Instead, it became a fun activity for workplace excursions, special tourist walks, and a solution for certain workers who needed to travel long distances at a slow pace, such as mall cops. Rather than the Segway, what really made a change in urban travel were electric bikes and electric scooters. Both are vehicles that didn't try to reinvent anything, but rather introduced measured incremental change instead. The electric bike added an electric engine to the old-fashioned bicycle, and the electric scooter did the same to the traditional push scooter. Now, what is true for urban mobility may be also true for high-speed, long-distance mobility, in the sense that in this field as well, the stakes are high and many ideas were explored and attempted. The incentive to cut travel time to distant locations has been very strong for centuries now, and the current situation reflects the best efforts of thousands of bright engineers and innovators who try to improve such systems. So what are the chances that these new Hyperloop attempts will reinvent the field of high-speed travel? I would say low, even before getting into the particulars, because it is another attempt at technological reinventism. Yet once we go into the particulars, it becomes even clearer. The Hyperloop technology is basically a mini maglev train set inside a tube that creates near vacuum conditions, allowing it to go very fast. In Hyperloop technology, high speed is achieved by reducing the two main friction points that regular trains have, with the tracks and with the air. While there are many known and unknown risks to using the Hyperloop technology, I will just focus on cost. As is, maglev technology is very expensive both to build and to operate. Although in the last few decades dozens of maglev projects were considered across the globe, only a handful of them are these days either operational or in the process of construction. This very slow pace of implementation also means that the cost reduction that usually comes as technologies mature and become widespread are slow to come to this field. Thus, while the maglev technology did prove itself to be sound in taking people from point A to point B at very high speeds, its implementation is still not very practical. Of course, the Hyperloop also needs to create near vacuum conditions by connecting special tube segments over long distances, which is costly in itself. Here, the technology isn't so true and tested and continues to experience hiccups, while new engineering challenges are arising as we speak. In addition, the Hyperloop's radical departure from what is now the standard high-speed technology of land transportation, the rapid train, also ensures that there will be no possibility of relying on existing infrastructure to reduce cost. So will the Hyperloop be the next Segway? Will it flop? Since I don't believe in technological determinism, I cannot say for sure. I can say that once innovators and developers enter into the mode of technological reinventism, with a stark confidence in their own ability to bring radical change, I become highly skeptic. My guess is that if the Hyperloop technology will succeed, it is because it will ultimately be stripped of many of its innovative features and reduced to some sort of incremental change to an existing technology. Long-standing engineering challenges, like that of mobility, are usually incompatible with audacious attempts to reinvent the wheel.